right. Welcome, everyone. Warm welcome to our SAP Community Call today. I'm glad to see so many of you here in our call. Very special SAP Community Call. It's a winner announcement of our SAP HANA Cloud Machine Learning Challenge. And I'm more than excited to be joined here today by our 3 winners of our challenge. I'm Lena from the SAP Community team, and we're hosting this call today with the SAP HANA Cloud team. So let me introduce the winners to you. It's Vishwas Madhuvashi, Sergiu Vishwas, and Clemens, who made it here on our virtual stage and won the challenge and are today able to present to you each for 15 minutes how they answered the main question, namely how to prevent employee churn by using SAP HANA Cloud's machine learning capabilities. The challenge ran for 3 weeks in the SAP community back in November until mid-December. And we had quite interesting solution paths, but you 3 made it. So congratulations here officially to every one of you. Before we start and before I hand over to Christoph from our SAP HANA Cloud expert team to give you a little bit more background on what the challenge really was about, let me briefly emphasize on the fact that we have time after Vishwas, Sergiu, and Clemens presented to all of you to address any questions that might come up during the presentations and that you have in general with regards to SAP HANA Cloud Machine Learning. So we have 10 to 15 minutes towards the end of this call to address these. Therefore, please log into YouTube here and type the questions in the chat. Already also let us know where you're tuning in from, how you're feeling today, and what's on your mind. So let's have a lively chat here today in our YouTube call. And with that being said, I'll hand over to Christoph to share his screen to give a little bit more background before then Vishwas will start with his first presentation.
Thank you so much, Lena, for the warm introduction and welcome. I just wanted to quickly recap what the challenge was about, how to predict employee churn. So we provided a data set about employee data with different features and certainly kind of an indicator that people kind of left the company. Flight risk was the column name. And then the challenge was for the participants of the challenge. We had about 20 people kind of actively participating and running their machine learning scenarios using the HANA Cloud machine learning libraries and capabilities to come up with a prediction model, which would then help the HR departments to, in the end, prevent employee churn. So the idea was kind of what can we find out in the data and guide and help the HR team to prevent employees in the different sections of the company to not leave the company. So for everybody who couldn't participate in the actual challenge, there are a couple of links here, which we'll also share and which you will certainly also find searching for them. The initial blog, we have a sample repository where we provided the data, so it's available for you to also kind of pick up the challenge even now or later in our HANA-ML samples repository. We had lots of great questions during the community challenge in our community thread. I've also shared the link here. And certainly then we have the winners blog, which Susan, our colleague, created. And really now with no further ado, we want to kind of learn from our winners how they approach the challenge and what were their solutions to the challenge. And with that, I hand over to Vishwas for his first solution presentation.
Thank you, Christoph. So let me start sharing my screen and talk through the solution. Can you see my screen now?
Yes, we can.
Okay. So the challenge was to predict the employee churn, and for that we had some data and some very clear objective. Let's see what the data was and what the objective was. So the context was that the companies want to retain their high performing employees and to reduce the churn rate of those employees. And right now the managers try to think about who can leave, and they try to prevent the attrition of those employees. But this is very subjective, not based upon data, and can be wrong most of the times. So the intent was to take a look at the concrete data and analyze the patterns of the employees churn and figure out which are the employees who are highly likely to attrit and stop them from leaving the company if they are valuable to the company. Managers will continue using their intuition for preventing the employee churn, but the intent of this challenge was to figure out which models can be developed to predict the churn of the employees at certain events, certain times, certain areas, and make sure that we can take the necessary steps before the churn becomes obvious, before they put in their papers, and use mathematics and data to arrive at the conclusions that we can rely upon. For this objective, we were given about a big set of data. We had about 90,000 samples with 42 independent variables, and we had one dependent variable called the flight risk. Out of these samples, we were able to figure out a few obvious groups, and we have marked them on the screen right now. One group was about the age. We had age group 10, age group 5, and generation. So we were able to reduce some of this data based upon finding the most obvious one, most useful one. Then we had a second group for the previous function area, previous job level, all those things from the previous job. Then we have one group about their location. We had current country, latitude, longitude, regions. We were able to drop some points from here as well. And finally, we had the flight risk as the fourth point here, which was the dependent variable. The data was synthetically generated, but it was supposed to mimic a real life scenario. The EDA insights for this were pretty interesting. But we found that 8 out of the 42 independent variables have equal number of missing values, which meant that there was something very common in these variables, and we were able to figure that they had all the same records had all the same missing values. We were able to drop some of the records to make sure that we were not counting the records of the missing data, and we were not able to generate those because they were related to the previous jobs. Since we could not create the data, we had to drop some records. One interesting and kind of disturbing thing was we found that there was some potential anomaly in the data. We saw that the 71.5% roles had been marked critical, and while 28 were marked as non-critical. So this seemed like an anomaly to us, and we have pointed this out to SAP, and hopefully with the correction of data, we can arrive at the better models. But this was one of the obvious outliers that we saw in the data itself. Correlations were not there, were not many. We did not find any significant correlation in the mathematical columns. The only 2 small correlations we found were in the time in previous position month and promotion within last 3 years, but the correlations were very minimal, just about 0.15, 0.17, not too high. So these correlations were not really significant. So we did not take away anything from this part. One thing that we found was that the age and job type were kind of correlated with the attrition. As the age increased, the attrition started dropping. In the 55 plus group, the attrition rate virtually drops to 0, while it is highest in the 20 to 30 group. There was one outlier though, the 45 to 50 group. But again, in general, the increase in age indicated the attrition rates kept going down with that. The other was that the temporary employees were more likely to attrite, and there is no surprise. So this was obvious, and this is visible in the graph at the bottom as well. Function and region were also a small scale indicator of the attrition. We saw that the people in sales and marketing were at a higher risk of attriting, and that's what we have marked in the graph above. Let me just highlight that as well. So this part. We also saw that the APJ region had the highest attrition rate, nearly double than other regions. So I think there may be something going on in the APJ region. So I think the APJ region and the sales and marketing departments had something going on that was contributing to the higher attrition rates. So this is one area that we should take a look at. We also found that the decreasing performance rating was a good indicator of attrition. So no surprise here. And also a demotion was a good indicator of the higher attrition. So no surprise here. The idea is, do we even want to stop these employees? If somebody has a decreasing performance, do we want to stop those employees? So I think we have to talk about with the HR to take a look at the next action for these employees. For pre-processing, we filled all the NaN values with unassigned, and then we split the data into 10 test and validation in the 80-10-10 ratio, and then we did all the pre-processing, and we went ahead with the model building. We found that the SAP made the life of a data scientist very easy. Had we not had all the functions available within SAP, we had to go through all these steps, dropping 12 columns, including dropping 12 columns, mapping 0 and 1 for the binary values, getting dummies. So all those things were kind of not required with SAP. So this was, I think, a lot of time saving happened to us because we were using SAP's machine learning solution. Let's take a look at the model insights. So for the first model, we use the gradient boosting binary classifier. And with this one, we were able to, and again, since we are trying to predict the churn, we are looking at recall as the value of interest. With this model, the recall value that we got was a low value, just about 55.1%, not really encouraging. Accuracy was good. Precision was not really encouraging either, and FN score was low. AUC was decent, but again, not really. But this model overall was not really encouraging. One thing that we point out here is that critical job role was low contributor here. And again, this is one more thing that I have pointed out earlier, that this is one area that may have impacted our models, and we should take a second look at this one. Also, one part is that salary was about, I think, 9th or 10th in the hierarchy. So funnily enough, salary has not featured as the top performing in any of the models. So salary is not the core concern of employees who are leaving the job. There are other factors, so we have to take a look at those more interestingly. Since model 1 was not really impressive, we went on to build 2 more models. So for the model 2, we use the random forest classifier. And in this model, we were able to achieve a recall value of nearly 94%. So this was better than the previous one. Accuracy was also reasonably good. FN score was decent. Precision was not really high, but again, given that recall is very high, precision was supposed to go low a bit, which is to be expected. In this also, the salary is far below. So I think we can safely say that salary is usually not the highest reason why the employees quit. There are various other things that we should take a look at, but salary is not one of those. And I don't see the critical role here in this at all. So I think critical role has done something. The data in critical role has done something to these models, and we should make sure to see that we have the right values for the critical role for all the employees. We also built one more model to ensure that we are on the right track. So for the model 3, we use the hybrid gradient boosting tree. And with this one, we were able to achieve a low recall value of 56.25%, not really encouraging. Accuracy was just about 66. Precision was very low. FN was very low. So this is not really a good model. And somehow the ROC curve stooped here in between. This was supposed to be smooth here, but this stooped here for some reason. We have to do some more research in this area. But again, this model was not also performing at the level expected. So we did not think that this was a great model to move ahead with. In this also, salary was pretty low. So the salary was number 7 here, I guess. But also I don't even see the critical role is not showing up here. It's very low. So salary is very low in the rating, and critical job role is also fairly low in this area as well. For deployment part, we believe that once we choose the right model, we have to look at several factors that can lead to employee attrition. And I have listed 10 factors here, which came from Vintage Circle. So these 10 factors, I'm pretty much sure that the HR is looking at these factors and making sure that these are taken care of. But the intent was to ensure that the best employees stay with us. We have to make sure that we run this model on certain critical events. And I have listed some events here. The annual appraisal is one critical event. Promotion is a critical event. Function/department change is also a very critical event. An employee's birthday, as the employees age, their attrition tendencies go down. Any major life event for an employee, marriage, separation, birth, death. So these are all the events where the employees are likely to make changes to their intent to attrite. And the idea is that the HR should run this model for these employees at these critical events and ensure what has changed. And based upon that, they should take some action. What we promote is that we should run this report weekly, and the HR should get this report by in a push model, not pull model. So they should get the report, and based on that report, they should define the actions for the next few months, few weeks, few days, few years, based upon what has happened. And based upon that, they should figure out what they have to do to ensure that the employees who are highly likely to attrite and that they want to retain are given what they need to stay in the company. The model should not be used en masse. They should be very particular to the employees. So it should be run only for those employees which have seen any major event in the last week or so, and the HR should get the report for only those employees and take action based upon that report. Our conclusion is that the model 2, the random forest classifier, is the one that has given us the best performance, about 94% recall value, and it makes sense to use with augmentation using over and under sampling. Data accuracy is a core role here, and we should ensure that the critical job role especially is defined well, and we take good care of the data that we are using. We should try to get more data and make better model based upon that. We must ensure to have a feedback loop to ensure that whatever you learn is passed back to the model, and the model keeps improving with every iteration of the run of this model. As you mentioned, the sales and marketing departments and the APG region had some tendency, has shown the tendency for people to attract more. So we should see what is happening in these regions and these departments to ensure that we can plug the gap and ensure that the best employees stay with us. Salary is not among top 5 contributors, so we can rest easy that salary is usually not the reason why the employees leave, and we should focus on the other factors. And finally, we should discuss with HR whether we should filter out the predictions of flight risk for the employees who have a decreasing performance rating and who have been demoted. Do we want to even retain them? We should talk to HR to ensure that we can take the right action and not burden HR with a full report of all the employees, even including those employees that the company doesn't want to retain. So these are the findings that we think are useful for the HR. And with this, I conclude my presentation and hand over to Christoph.
Sergiu is next. Thank you, Vishwas.
Okay, I'll unmute. I'll share my screen. Okay, can you see my screen? Yes. Yes, we can. Yeah, it's okay. Yeah. Well, thank you. Thank you for inviting me.
Well, after the challenge, I published the entire Jupyter notebook on GitHub, and afterwards, in a few weeks, in January, I also decided to publish a blog where I explain the main parts from the Jupyter notebook. So I'll try to do my best to explain in my next 15 minutes. Okay, so we already know that this is about we already know that we have to predict the employee churn, as already Vishwas mentioned, and for that the first step is to install Anaconda and create my environment. And I also installed my HANA ML. What I like about HANA machine learning is that I can access it from my local Jupyter notebook, and I can write code in Python. And this, in Python, everything is an objects, and HANA machine learning objects are just like any other objects, and I can wrap them in function. I can use them in lists and dictionary, and get a very clean and reusable code. So understanding the challenge, looking into the data, I can see that our data is highly imbalanced. We have two classes. The first class is no class. This is a majority class. And the next class is yes class, the class we have to predict. And this class is our minority class. Well, the next step is to look into data and look into feature distribution. I also filled the missing values, did some feature engineering by creating new features. So I'm ready to go to my next step and see what I can get from this data so I can build a model. To do so, I have to split data into train data and test data. I used only one function, only one library, which I wrapped in a function. I used only hybrid gradient boosting tree. So this is a function where I wrapped everything. After I fit the model, I can look into my statistics. Well, looking just into model statistics, I can consider myself lucky if I'll take into consideration only accuracy, because I have an accuracy of 0.92. But as I mentioned above, I know that my classes are highly imbalanced, so I cannot rely on accuracy. I have to rely only on recall, and for that, I created a new chapter, understanding statistics, and I explain why in imbalanced classes we have to rely only on recall, and what should we do next to rely also on accuracy. So this is a very detailed example. One, recall is about true no and true yes. So I will not go into details here because it will take some time, but we can look into the blog afterwards if we'll have time. So after also I did my prediction, I output the prediction statistics, and looking into prediction statistics, I also can see it's wrong. Something wrong. Okay, looking into prediction statistics, I can see that my recall is 0.034, and that's very poor. I will store all these initial results in local data frame, so I can look into all my results at the end. So meanwhile, we received additional data, and with this additional data, I built again the model. I joined all this data, and looking into recall, I can see a very good improvement. The recall is jumping into 0.6. And also looking into prediction statistics, I can see that my recall is 0.57. It's slightly under the model statistic, but this is good. The next step is to reducing the number of features. To do that, I have grouped the features by, I have grouped features into, I have grouped the dependent features. You can see the groups, and from each group, I selected only one feature by importance. Also, I did some adjustments. For instance, for previous country, I selected in case of countries, I prefer to adjust the selection with top previous countries and current countries. Something is going on my mouse, yeah. And looking at prediction with looking at the prediction statistics, I can see that my recall for yes is 0.62. Well, probably think we received even more data. No, we didn't, but we have some very powerful tool. It's SMOTE. SMOTE is about synthetic minority oversampling technique. I will do one more time I will check one more time the class proportions. I can see it here. I can see that my class yes is highly imbalanced, and I have to calculate the maximum amount for from my SMOTE. So the max amount is 710. Well, I will apply this function, and I will get my training data below, and the training data are balanced. We can see it from the output. So I would like to look into my prediction statistics, and here we have this big surprise. My recall yes is 0.8, and this is a very big improvement of my SMOTE, so I'll keep this SMOTE. I also can look into my prediction statistics, and I can see that my recall is 0.79. It's almost the same. So I can go to the next step. And this is, I will call it a kind of a magic step, because I will do double magic. I will balance my test data, and also I will increase my training data. Why I should do this balancing? Because I would like to use also accuracy for my prediction, for my prediction statistics. So you can see that I balanced my test data, and at the same time, I have increased my training data. You see an increase here. I will apply the SMOTE to the training data. I will use all these classes, all this function I built before. I can see that my training data are balanced, they are equal. Well, I can look into my prediction statistics, and looking into my prediction statistics, the recall for yes is jumping, is 0.82, and looking at the support, we can see that our support is 210 for no and 210 for yes. And that means that we can rely on accuracy. And my accuracy in this case is 0.87. Well, what I did above is top SMOTE. It was just the first try, but I would like also to explore it more. What does it mean? I would like to do it step by step by increasing in each step with 100. And then I will choose from all these models. I will choose the best one based on my accuracy, on my prediction accuracy, because as I said above, I can rely at this moment also on my accuracy. Yeah? So this is a very intensive process. Everything is done in HANA. Well, no, just Sorry for that. It was here. It was about finding top smooth. Yeah. It took about 8 minutes. It took about 8 minutes. And at the end, I can look into all the models. I've got the models here and accuracy. And I can see that the smooth with 700 is the best one. Now I can move to the next step, building top models. And in building top models, I would like to add the features one by one in order of importance. So I also created one function to wrap everything. And this is also a very, very intensive process. It took about 21 minutes. Well, you can relax, enjoy a cup of coffee or of tea. I did so, but the code is already executed here. So we are looking just into the data. And we have a great surprise, yeah, because we can see here that the best smooth with the best top 15 features gives me an accuracy of 0.89. I stored all these models and other dependencies in a dictionary. And as I said before, I like HANA machine learning libraries that everything is object. And you can see in this output that the model is just stored in this list along with all others dependencies, which are local. And I'll go to, I have this last, I have this table, I have this data frame with all the results, but I'll switch to GitHub, yeah, because I can show here all the progress. So what did we have at the beginning? Yes, we have this initial data, and our recall yes was only 0.34. And then we have additional data, and our recall increased. And then I tried to reduce the number of features, and we've got an increase. And then I decided to do some manual adjustments, and I've got almost the same recall. And in the next step, I applied this powerful tool, Smooth, and with Smooth, we've got this big increase of recall to 0.8. Well, I did the same with importance statistics. Then I decided in the next step to balance my test data, and you can see that my support is 210 here and 210 here. Yeah, and at this stage, at this step, I can rely also on accuracy, and my accuracy is 0.87, and I will do the same with best smooth. And finally, I'll do the same with my top features. And I've got this best result of 0.89. Switching back to the blog. Well, analyzing top models. Well, machine learning is not a black box. Yeah, we can ask some questions, and the response, the answers to our questions, it's a reason code. For each prediction, I can get some explanation. For instance, the reason code, the top reason code for first prediction is sick day for the next one, and training for the next one, and so on. I can ask even more questions, yes, and for the same prediction, I would like to receive even more answers to give me top 5 reason codes. And I can do about, well, something is, okay, I got it, okay. So we've seen only data above, but also we can visualize all these statistics. We have plots, we have a very powerful library, unified report. We can see all this importance we have seen before as a chart. We can see also we can output other statistics, model statistics. Then we can have explanation from the prediction, and we can see the contribution of each features And for that, we can use Shapely Explainer. This is a plot from Shapely Explainer. Also, everything I described above about recall and accuracy, we can understand better with the confusion matrix. This is a model. This is a confusion matrix for model. We can take a look at this also normalized. And also we can look at the prediction statistics we can look at confusion metrics. We can look at confusion metrics of prediction. And we can see that we have here false no 32 and true no yes is 178. And if we sum that, we'll get 201. Yeah, so and above you will get the same value, meaning that our test data have been balanced, and we can rely on all statistics, recall, accuracy, precision, F1 score, and so on. What about further steps? Well, machine learning has many steps. Well, we have collection data, and then we have to build all these models. And the model is the brain, but this brain needs a body. So the body, in our case, is an application. And we should further think about how we can deploy these models. As I said at the beginning, my scope was to provide different alternatives to the same model. So because in deployment, during the deployment, I would like to use different models, so I'll be able to compare, to do some kind of A/B tests. So that's actually everything about my model and my results.
Thank you, Sergiu. You can hand over
Thank
to
you all.
Clemens. Thanks. You can unshare your screen, Sergiu. Okay. Let's continue.
So, can you see my screen?
Yes, we can.
Okay, perfect. Yeah, so hello, everyone. My name is Clemens. I'm from Austria. I'm a consultant at STT. And yeah, so I'm consulting business and analytics and planning. And the STT is one of the leading SAP service providers in Austria. And we are happy to share our expertise, inventiveness, and passions to get the best out of their business every day from our customers. And we're also a long-standing partner of SAP and covering the entire SAP solution portfolio. So yeah, and I'm also very happy that I got the opportunity to get in this challenge. And yeah, so I want to share my insights about the challenge. The first thing was that we heard today that it is the aim that we want to predict the employees which want to quit. But another aim I also wanted to implement is how to do something against, like what can the data do that we can do against it. And the first thing as a data scientist, you're doing and looking into the data and to get a little bit of feeling of it. And yeah, so I created some numeric histograms from the numerical variables and also a correlation matrix. So you can see here, but as Vishwas mentioned before, you can't find something significant. So it's very clear. And the tenure amount with the age, that's very clear that it's positive correlated, and the salary with the age. So yes, and if you look at the numerical values, the only thing I can find was the salary, because if you look, there is just a huge amount of people who are earning the most of the 120,000. But the other things are pretty much normal distributed, and you can't see anything special from it. I also tried to split it up to compare the people who've quitted the job and who quitted not. So like from the salary or from the age, and there was nothing special significantly. So it was almost the same. And yes. And another thing was the, so I have to get to the next slide. So yes, another thing what was that the data is very imbalanced. So you can see that for the company, it's very good that the most people are staying and just a small amount of employees are quitting. But as a view, as a data scientist, it's not a really perfect scenario because you really want to find the people who are quitting. And if this is a minority class, then it's getting harder. And the SAP HAL has an implementation to balance the data. So it's called the small tag. And the small tag is this mode that you doing the data points which are existing from the yes, that you are not duplicating it, but you are creating synthetic data points. And Tomek algorithm is to reduce the no class. And that's what I've done, and very aggressively. So I almost balanced it from 1-to-1. And that was the first approach before I got to the modeling. And then, if I started with the modeling, I decided for the hardware creating boosting tree model. And it's very nice that if you use the SAP PAL, you can also do some grid search, and because it's all calculated in the server at HANA.ml, so you can use the compute resources from it. And to find the best and the optimal parameters, I did a grid search, and I let it run for some time, and it's very fast, so I don't know anymore. It's about 20 minutes, 40 minutes, and I played a lot around with it. And the perfect parameters was for the model 1, 0.1 for the learning rate, and 120 estimators, and a split threshold from 0.1. And the thing is also that that it's very nice that you just like can run it on the server and calculate it. The first, and here are all features involved in this. So I haven't done something feature selection, and here are all in it. And I got a really nice precision from 97% of no, and from the yes, precision from 73 almost. So yes, this is the detection that we can find it, and here you can also see the correlation matrix. So from the yes, we got 325 right and just 121 wrong. What you also can do and see for the model is you get, if you predict something, you get the confidence score, and you also get the reason code from the model. And here you can see why, so it's not the black box, you can see why the model is giving it the score yes, for example, employee which are quitting, sorry. And yes, so this is the model 1. And the idea of the model 2 was to just select the top 15 features which are involved in the model 1. So for example, HR trading, functional error change type, sick days, and so on. And I have done this again with the hardware gradient boosting tree. I did a grid search. The optimal parameters was a little bit other, so different. So it was like learning rate 0.4, estimators was the same with 120, and the split threshold with 0.3. But the thing is, I didn't get this good result at the model before. So the precision from no is quite the same with 97%. But the precision with yes, it is a little bit weaker. So I just got 68% of it. So the model 1 and the model 2, I would suggest to use the model 1 with all the features, even if we have some other noise in the data because of other features and so on. But the class we want to predict is yes, and here is like we want to find the most highest precision. We want to find all the employees who are quitting. So this is my first approach. And the second one is what can we do now? If we can find now the employees which are quitting, who are quitting, then what can we do? And what can we do just if we have the data from it? And if we go now here, what I've done is I use the top 5 features from the model and just looked into the data, what it's different. Why is the model predicting like that kind of? And the most top feature is HR training. And it has an influence of 28% of the model. So it's quite a huge influence in this. And the funny thing, or I don't know, for the company, it's not funny, but if you look here on the left side, you have the employees which are quitting. And on the right side, you have the employees which are not quitting. And if you look at the employees who are quitting, you have a really big amount who did the HR training, and a small amount who didn't have done the HR training. And if you look at the people, the employees which are still at the company, it's in the other direction. So yeah, I don't know what they do in the company, the HR training, what they are teaching, what they are learning, but yeah, that is one indicator that it's not really beneficial for the company. The second top feature was the functional area change type that has an influence of 9% of the model. And I did the same. So I split it into 2 groups with the flight risk yes and flight risk no. And here you can see that that no change is also a huge amount in the employees which are still there. But if you look at the cross-functional move, so there's a significant difference between the flight risk yes and the flight risk no group. So if you so my suggestion is to use this in the company and to provide cross-functional move to prevent employee churn. Then the third feature was the sick days. And here is the same. On the left side, you see the people who are quitted their job, and on the right side, who are still at the company. And I also printed the mean from the flight risk no amount at the flight risk yes. So the green line is the mean from the sick days of the people who are still at the company. And the thing is that people who are employees which are quitting their job have more sick days than the employees who are staying. And for me, it is like I would suggest as an indicator around 11 sick days. So if the employee has more than 11 sick days, then maybe it can be that the employee will quit. For example, maybe also if he did the HR training. And the fourth was the employment type. So in the data, there was temporary and regular. So temporary means that they have a temporary contract, and the other one is just a normal contract. So the temporary is limited to a date, and people, employees, they are quitting their jobs more when they have a temporary employment contract and looking for. So it's logical because they are looking for another job before the contract expires, and then they are switching companies. So that can be, but it's also they are not happy maybe with it, because we can see it in the data that there is a difference. And the last feature was the promotion within last 3 years. And there's also a big difference. So if you look at people which are leaving the company, they are not have a promotion in the last 3 years. So it's not, it's really huge, the difference. And if you look at the people which are still staying, they have around 5,000 employees. They have a promotion, and near 12,000 employees, they have no promotion, still staying. But that's also like something what you can do. So if you have high level skilled employees, you can prevent them maybe with promotion. And yeah, so that's the addition. What you can do if you if you detect employees which are maybe leaving, then you can check these features and check what have they done. And then you can hopefully prevent the employee for churning. So yeah, that was my solution. And thank you. Yes.
Thank you, Clemens. Thanks for sharing. You can unshare and let's all go back on camera for the Q&A. Perfect timing.
Okay. I'm back.
Brilliant. Clemens, you're still sharing?
Yes.
There we are.
It's off. Yeah.
Everyone's back. Thank you, everyone, to you for sharing your presentation. It's very interesting that the HR training can actually be negatively impacting employees to leave a company. Interesting. Any comments from our expert team here on the presentations?
Yeah, fabulous presentations again. I think that was really, really cool by all of you. I think very interesting also to see the difference, kind of the different approaches you've been taking to tackle the challenge. So I think everybody, even today, learned a lot about how easy or maybe challenging it was to tackle the ML challenge. And actually, I would have a question. I mean, you've all been new to HANA machine learning and the Python interface and used open source before. And I think you commented a little bit about it already, but I would really like to learn maybe how easy did you find it to maybe go from something like scikit-learn and Pandas data frame to the HANA data frame and the HANA machine learning function. So it looks kind of, you did a great job and explored it in such a detail I would have never expected. So that's fantastic. But was that actually a big challenge for you, or did you find it easy to pivot, let's say, from scikit-learn to HANA ML?
So Christoph, I can start. And I think I mentioned to you the challenges also that I was trying to think about using TensorFlow and all those things for this challenge. But again, then I discussed with you and realized that the intent was to use SAP ML. And I was a bit reluctant initially, but again, when I started using it, I found that it was very easy. There was a small learning curve, of course, but again, I think the what we have in SAP ML is really really highly useful and pretty concise also. One thing that I thought could be done better is that there is some I think there is some lacking documentation that would have made my life much more easier. But again, it was not at all hard. But again, some more documentation would help other learners to ramp up more quickly.
Thank you. Maybe a comment from Sergiu or Clemens on this as well.
Yeah, it took me about 3 days to understand how it works, because I had previously different proof of concepts. I even built something with ABAP, just as a proof of concept. And the main part was about data frame, because it's a little bit different, but about machine learning libraries, they are very well aligned with open source libraries. So as you've seen in the thread, it took me about 3 days to get the idea, and then to get even more examples, different pieces of code, and then to put everything in function and run everything from one end to end.
Okay, super. Thank you.
Yeah, from my side, it was also the same. So the data frames was a little different, and you have to get know it, but the learning curve is very steep. So you're learning pretty fast the handling of the tool. And you also have the advantage then that you can run it on the server, and you don't have to run it locally. So it's also like beneficial for you that that you are using the SAP HANA ML data frames. Mm-hmm. But they are also like providing a lot of features with SQL to get the views of the data. And the machine learning is pretty the same. Yeah. So also the grid search and so on, all just different functions name, but the most are pretty the same. So it was also easy for me, yes.
Okay. Thank you.
I'd also like to comment one thing. Oh, so Sergiu, go ahead.
Yeah. There is one more thing. I noticed there are some functions that are embedded into the models. For instance, if you'll use open source XGBoost, you'll have to encode features. But in hybrid, you don't have to encode features. And also, if you use open source XGBoost, you have to specify all the features. But in hybrid, you don't have to specify the features, because the exact number of features. It will take it from the initial data. So I didn't have time to explore everything, but I've noticed that there are a lot of functions embedded in library. Otherwise, in open source, you'll have to handle it by yourself.
Okay, thank you. Cool.
My comment was about giving kudos to the SAP HANA Cloud Expert team, because I think it's interesting to know how long it took you to read into it, etc. And I think in addition to you being brilliant to invest your time in like reading into it and doing the challenge, I think it was brilliantly organized by the SAP HANA Cloud team to offer open office hours to everyone in the SAP community that had questions regarding the challenge or questions in general about machine learning. So they also invested a lot of time out of their busy schedules to be there for the SAP community and to offer their help and knowledge to everyone. So big kudos also to everyone here on the Orga team. With that being said, I also just, as Christoph mentioned in the beginning, pasted Susan's summary announcement blog post into the chat for everyone to reread. And I'd like to thank you all for taking your time today. It's been a pleasure to have you here on our SAP Community Call. I hope you enjoyed it too.
Yeah,
big thumbs up. Okay, great. Right. And yeah, you were on mute, Sergiu.
Yeah, I was on mute. I'm alive. I have hands, so I'm not an artificial intelligence. I'm just a live being.
All right. Okay, then thanks everyone. Take good care, and I hope to see you in our next potential SAP HANA Cloud Machine Learning Challenge.
Yeah, thank you all.
Thanks a lot.
Thank you all.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.